I lapsed into a total differential type thing when I wrote out what was here previously. So here's what I need to look at first. I can get to the other thing, but I'm going to just kind of stop with this, and then maybe the partial of f with respect to v. Okay, so here we have partial of a function of xy with respect to u, where x and y are both functions of u and another variable v. Okay. The partial with respect to u depends on how fast a change in u changes x and how fast a change in u changes y. Okay, so what we get is take the partial of f with respect to x, which tells you how fast a change in x makes x squared plus y cubed change, multiplied by how fast a change in u causes x to change. Here, you multiply how fast this function changes with respect to y by how fast y changes with respect to u. And that gives you how fast this whole thing changes with respect to u. Now, derivative f with respect to x is pretty simple. That's 2x times the partial of x with respect to u. That's 1 over v. Now, even though we're just doing the partial with respect to u, the value of v naturally does impact the value of x and even the rate of change of x. So right there's the rate at which x changes with respect to u. And obviously derivative of this u over v with respect to u is 1 over v. I think it's obvious. It's late in the day anyway. Okay, so that's this term. And then the partial of f with respect to y, which is 3y squared, times the partial of y with respect to u, and that's just v. Now, of course, x could be written u over v. So you'd have 2u over v times 1 over v would be 2u over v squared, and y squared would be u squared v squared times v would be u squared v cubed times 3 and so forth. We can do that. We could write this whole thing in terms of u and v just by saying that now the function's u squared over v squared plus u cubed times v cubed. We do the derivative of that with respect to u. And you want to do it both ways to understand this. Okay. So we could then say that this is u over v squared plus 3u squared v squared. And then, of course, we could do, and it follows pretty easily, partial with respect to v of x squared plus y squared. Again, we could just, instead of x squared plus y squared, write u squared over v squared plus u squared v squared, u cubed v cubed, because this is y cubed, okay? So you wonder why we go to this trouble. Well, you want to have the alternative. Also, the alternative actually gives you more information, okay? Applying the chain rule gives you a little more information. Okay, well, that's the rate at which x drives a change in this function times the rate at which x changes with respect to u plus the rate at which the function changes with respect to y times the rate at which y changes with respect to v. And this isn't u, this should be v, because it's partial with respect to v. Okay? So again, v makes x change at this rate, and this is how fast f changes with respect to x. So This is how much a change in V drives X to change, and this is how then much, or the rate at which X drives a change in F. And then same thing with Y. Change in V makes Y change. Change in Y makes F change. And these are the rates. Okay, and it's easy to calculate, of course. These are really easy to calculate. This is 2X, just like it was up here, but now X changes with respect to V. And that rate is negative U over V squared. Then partial of F with respect to Y is 3Y squared. And the partial of Y with respect to V is just U. And then we can write this out in terms of U and V. I'll go ahead and do it. X is U over V, so this is negative U squared over V cubed. And Y is UV, so this is 3U cubed V squared. No great insight from this or this, but often that's what you want to do, so that's what I'm showing you. Okay, well, your book's going to write out the rules in a little more general form. You're going to have examples. And it really isn't that difficult to understand if you keep thinking about it in terms of the rates of change that are involved. How one rate drives a change in this variable, and then the change in this variable drives a change in your function. And of course you can go several steps. You know, you could have a function of a function of a function and so forth.